The second lecture of 8.2 is going to deal with triangles. We've already talked a little bit about triangles, the idea of an equilateral and isosceles. An equilateral basically says they have three equal sides. So the sides of the triangle are the same. So if the sides of the triangle are the same, that means the angle that opens up to get the sides these three angles must also be the same measure. And we'll talk about what that measure is later on. From last lecture, we discovered that they are 60 degrees. An isosceles then is when I have two equal sides. So these sides are equal in length, and then a scalene is when I have no sides equal. So we're going to classify triangles as equilateral, isosceles, or scalene. Within the triangle, we look at the size of the angles, and we classify triangle names by also the size of their angles. So if I have a right triangle, it has an angle equal to 90 degrees. If I have an obtuse triangle, it has an angle which is greater than 90 degrees. And if I have an acute triangle, that angle is going to be less than 90 degrees. Notice I didn't get into the 180 business yet. We'll be talking about angles of a triangle, and we'll come back and do this property as an exploration. So we'll wait to tell you what that's going to be. Line segments. If I have a triangle and I'm looking for the median goes from the vertex of the triangle to the midpoint of the opposite side. So if I have a triangle and I want to find the median, it goes from the vertex to the midpoint of the opposite side. Notice it's slanted. That would be a median. An angle bisector is a segment that bisects the angle. So in the triangle, I'd have three angles that would be bisected. So once again, if I have some triangle here, and I bisect the angle, that splits it right down the middle. And so we're going to note that this angle, and I put a line through it, is congruent to this. They are the same size. A perpendicular bisector goes to the middle or midpoint of a side. So it goes from the midpoint of a side of the triangle and is perpendicular. So what would that look like? Well, if I have a triangle and I take, and let's see, the midpoint of a side and runs perpendicular. Notice it doesn't go through the vertex of the side opposite. That was a median. This just goes perpendicular to the side that I'm bisecting. An altitude is also perpendicular. So it's a perpendicular line segment from the vertex to opposite side. So that's what we call an altitude. So what would that look like? Well, if I have some triangle, the altitude runs here perpendicular, and it forms a perpendicular line as this formed there. Okay, so it's a line perpendicular from the vertex to the side opposite. Sometimes the altitude lies outside of the triangle. So I might have a triangle that runs like this, and if I'm going from this vertex to the side opposite perpendicular, this would be my altitude. Altitude sometimes is referred to as the height. Now, we have these points of concurrency. In other words, this point where these three line segments that we formed above are going to meet. We're going to do these in an exploration, at least a couple of them. The centroid is where the three medians intersect. So if we go back up and look at this median, it's where those three medians are going to intersect. So I take the median of each one, and that's going to be the intersecting points, a centroid point. The circumcenter is going to be the point where the three perpendicular bisectors meet. The incenter is where the angle bisectors meet. Again, we'll talk about what's so important about these points within these triangles. And the orthocenter is going to be where the three altitudes meet. And again, we'll talk about the importance of this concept called an orthocenter.